to start off with the Cambridge O-Level Physics Alternate to Practical, which is paper 4, and the code for this paper is 5054/41, and this is October-November 2022 paper. Let's start off with our first question, and it states that a student measured the refractive index of oil. Oil is poured in a semicircular transparent plastic container as shown in the figure 1.1. The container is placed on the top of a 360 protractor as shown in figure 1.2. The line AB shows the position of the flat side of the plastic container. A ray of light is incident at the midpoint of AB with an angle of incident I equals to 30 degree as shown in figure 1.2. State one property of the oil that is needed to be ensured that the experiments work. So for this, we need to know that the oil should be transparent so that we can find out the refractive index. Figure 1.2 measures the angle of a refraction of the light in the oil. So we have to measure this angle. So first of all, we have to identify which one is the normal line. So I'll use the red color to find out the normal line is going to be this one, and over here is going to be this one, the perpendicular line. So this is going to be your angle of incidence, because this is making an angle with the normal, and this is going to be your angle of refraction, and this is what we have to measure. Okay, this is like 90, this is going to be like 100, and this is going to be 110. So you can see this is 10, this is again 10, and this is going to be 1. So I'll write it down 21 over here, so which is your right angle. So degree sign is already there, so no need to put this sign over here. Moving to the next question, and this question states that the student repeats the procedure described in A and measures the angle of refraction R for the angle of incident I equals to 15, 45, 60 degree and 75. The results are shown over here. So what we have calculated over here, so first of all I'll complete that table. So it's going to be this one. On the grid provided in figure 1.3, show plot a graph of R on y-axis. So we are going to put on the y-axis is going to be the R, and the state the axis 0, 0, and this, and I on the x-axis. So this is going to be I on the x-axis. So I'll plot the values. Okay, so this is the values I have got it from the table, which is like this one, table 1.1. So you might draw it properly just to give you an idea how it's going to be drawn in this graph. Describe a relationship between I and R shown by the graph. So it's not going to be a straight line, not a straight line. So it's a 1 mark question, so you can obviously tell, and it is a curve. So obviously it's not a straight line, so this is what it is. So angle of incident is increased, so does the angle of refraction is going to be increased in this case. Use the graph to find out the value of R when I is equals to 50. So when I equals to 50, you draw this line up till this point, and then I'm sorry, again this is like I'm doing on a tab, it's going to be a rough sketch. So it's going to be like this is going to be your value, which is around 34. 1 2 3 4, okay, sort of 34 things. Okay, so I told you already this is a rough sketch, just to give you an idea how things are going to be done. And make sure you use a proper lead pencil, that is going to be a clutch pencil, because it's going to give you a proper the linings are very neat and clean. Okay, don't repeat this thing, don't repeat the lines on the curves. Theory suggests that the refractive index N of the oil is given by sin I over R. By using I and using your value in this, calculate the value of N, give you an answer to appropriate number of significant figures. So what I'm going to do is sin 50 divided by sin 34, and it's going to be N equals to, this is refractive index, so I'm going to like 1.4 will be your answer. It's basically the two significant rule. On the figure 1.1, sketch the graph where R is plotted against I. No calculations are required. So what you are going to do is, this is sin R, sin I, sin R over sin I is equals to 1 over 1.4, which is going to be like 1 over n. So what you are going to suggest one reason why the practical method used in this investigation might not give an accurate value for n. Okay, the next question is, suggest one reason why the practical method used in an investigation might not give an accurate value of for n. So obviously light has been refracted from the plastic container, and you will get an inaccurate line of best fit. So moving to the next question, and it states that a student investigate the cooling of a water. The apparatus used in this figure are these, and explain why the water is stirred before taking the temperature reading. So obviously, it's going to ensure the whole temperature is uniform. So one is going to stir the liquid water. The student uses 200 centimeter cube of hot water in the same beaker in each test. State one and other experiment variable that student keeps constant to make a fair comparison of these three sets. So it can be initial temperature, that should be kept same, and again you can have the same at same room temperature. Then the room temperature must not be varied. Okay, this is figure 2.1 shows, oh sorry, table 2.1 shows the results obtained by the students, and this is trial 1, trial 2, and trial 3. So again, this is average, so you just add 82 plus 84 plus 82 divided by 3, and you will end up 82.66. This is 3, so this is going to be 82, rounding off. Complete the table for 2.1 by this we have already done. Suggest one reason why the time taken for the water to cool by 10 degrees is not double the time taken for this. So as the temperature is going to be decreased, the temperature between the water, temperature between water and surrounding is going to also decrease. So initial temperature is not high at this point. You can also write this as well. The student repeats the experiments using 250 centimeter cube beaker. All other experiment variable remain same. Table 2.1 shows the average time taken for 250 centimeter cube beaker to cool by 5 degrees Celsius, and by 10 degrees Celsius it's going to be this. Table 2.1 is like this. Describe the difference in cooling of the water in two beakers. Refer to the results recorded in 2.1 and 2 in your results. Okay, by looking at table 2.1 and table 2.2, so what we are going to do is, like, if you talk about beaker which has a volume of 250 centimeter cube, so over here this is going to be like 5 degrees Celsius temperature has been decreased, and it has taken 27 seconds. How it has taken 27 seconds? Like, you have to subtract 110 out of 83, so you have to compare this thing. So this is the difference, and it's going to be like 27. It takes 27 seconds to fall to this temperature, which is 5 degrees. In comparison with the beaker which has 500 centimeter cube, and the temperature which was going to be decreased, it's going to be like 69 seconds. 69 seconds, and I'll write it over here. So this is going to be like 250, this one, minus the time from the table 2.1, which is going to be 181 seconds. So it's going to be 69 seconds. So this is how you do it. Okay. I'll do one more thing so that I can write it down. For 5 degrees Celsius, the time taken was 83 seconds, and this time is from table 1.1, sorry, 2.1. And for this is like 10 degrees Celsius, it was like 181. So I have taken this value from table 2.1, and this is going to be this value. So just the reason for the difference. So obviously the surface area is small as compared to the bigger beaker. 500 centimeter cube beaker. Okay, so it's a 1 mark question. Okay, now a student measures the density of a sample of a modeling clay. This clay is molded into a cube as shown in the figure 3.1. Suggest one difficulty in the student finding when molding the clay in the cube. So now you see this is not a proper cube. These sides are like irregular in shape. So this is the first difficulty that he is going to be having in making this cube. So what you have to do is edges straights, they are not straight, but it's going to be a problem for him to make a straight edges, or they are not properly perpendicular. On the figure, measure the length d. So now again the word is measure. So you put a scale over here and you can measure this thing. So I have done this and it was like 2.4 centimeter. So unit is already written. So I am going to ignore that thing again. Then is calculate the volume V of the molding clay using the equation. So 2.4 cube. So if you find out on your calculator, there's going to be 13.8 centimeter cube. So that's an easy question. Again, calculate the density of this question. So you know the mass, and the mass of this clay is this one. You are going to put 36.3 over here, and the volume is 13.8. So you can write it down 2.6 grams. This is the unit per centimeter cube. So this is going to be your final answer. Okay, the student investigates the current in a resistor of a fixed resistor. He has following apparatus state which piece of apparatus is used to measure the current. So it's going to be the ammeter, which is used to measure the current. Draw the circuit diagram to show the circuit student uses. You may use all the apparatus available. Okay, so first we are going to make the 6-volt battery, then it's going to be connected with the ammeter. It's going to be your variable resistor, then it's going to be your fixed resistor, and then it's connected with this one, and then you are going to attach a voltmeter across this. So this is going to be your final answer. Describe how the student obtained the different values of the potential differences across the fixed resistor. So you have to find just adjust the variable resistor, adjust the variable resistor, or change the values from the variable resistance, and you will get different values of potential difference fixed resistor. So that's it. Thank you very much.